In this video, we are going to learn scatter charts in Excel. Scatter charts are used to understand the correlationship relatedness between two data variables. A scatter plot has dots where each dot represents two values, x-axis value and y-axis value, and based on these values, these dots are positioned in the chart as we see in the below chart. Let's go to our Excel file to understand this better. Here I have a table with independent variable and dependent variable. We have the distance in kilometers here and the travel time to cover this distance. These are just random numbers, but you can find a correlationship here. For 350 kilometers, if you travel by train, then you may reach the destination within 3 hours. For 85 kilometers, if you travel by local bus, that we may need 3.3 hours to reach the destination of 85 kilometers. This way we can change the mode of transport, and depending upon the mode of transport we can decide the time taken or time needed to travel that distance. And these are just the random numbers that we have here, and of course a little logic can be used based on the transport mode. Considering this independent and the dependent variable, we can use scatter plot to understand the correlationship between these two variables. Let's see how to check that. Let me select these two columns, go to insert, and we see the scatter plot here. Select this. This is how our scatter plot looks like, where we have our total kilometers in x-axis and the graph is plotted for the time hours or the travel hours. Using the dotted plots like this, it's difficult to understand the correlationship between the independent and the dependent variables. Let's draw a trend line to understand this correlationship in a little better way. To draw a trend line, go to add chart element. We see trend lines here. By default it's none. You can use linear or go to more trending options. We see many trend line options here, and by default it's selected as linear. You can check the exponential. Polynomial can be mentioned in different orders. When I change the order to 6, I see the curves are a little prominent. Although this is not the best fit trend line, but for now let me keep this as linear because I don't see any other best fit trend lines here. When I select the moving area, it has too many different curves, not covering all the scatter plots. This again does not cover all the plots, although this slightly covers the plot area. But let me select the linear plot. Although this is not the best fit, let's keep the linear trend line for now. We see there are two options here, which is display equation on chart and display r-square value on chart. Let's click both. We see the equation and the r-square value here. Let's keep it aside. The trend line is not very much visible, it's not very much prominent, so let's change the design of this trend line. Let me give a solid color with a dark appearance, and let me increase the dot width. I don't need the dots, let me keep it as a straight line. Now we have our trend line like this here, and the scatter plots scattered all over the chart. After drawing the trend line, we see that there is no much of a correlation between all these scattered plots with the independent and the dependent variable. There are very few correlations, but not all the variables are correlated. That is what the trend line shows us. We see our formula here. As per the formula here, it says y is equal to 0.0019x plus 2.4737. R square is the coefficient of determination, and if r square is nearing to 0 or 0, it means that these two variables, x and y variables, have no correlationship between each other. They're completely independent and there's no relationship between these two. If the r square value is almost nearing to 1, like 0 0.8 or 0 0.9, somewhere nearing to 1, or if it is 1, it means that these two variables are very much correlated to each other, very much dependent on each other. In our case, we have 0.02 as our r square value, which is not so good. It's almost as good as not having any correlation between the x and the y variable, because as we see here, not all those dots are completely aligned with the trend line. It's not completely related with the distance and the travel time. We use scatter plot along with the trend line for those data where we see that there is a sort of correlation between the dependent and the independent variable. But if you want to know the exact number of correlation, how good it is, how fit it is to have that correlation between each other, we can use this plot to understand the strength of the correlation. As I mentioned, if r square is almost near to 0, we can see that there is no strong correlation between the variables. And if the r square value is almost nearing to 1, we can see that there is a strong correlation between these two variables. And the equation will help us understand the exact points of those correlation values. Let's understand the highlights of the scatter plot along with the trend line. The aim of this chart is to see whether there is any correlation between the dependent and the independent variable, that is the kilometer distance versus the travel time in hours. The trend line in the scatter chart shows whether there is any positive or negative correlation between the data. In our case, we saw that it was not so positive. It was almost as good as no correlation between these two. Microsoft Excel allows us to display the trend line equation and r square value in the chart to understand the correlation dependency between the dependent and the independent variables.